Greetings, fellow students. I'm Mate.
I'm Rix.
And I'm Cramer.
And today we're going to learn about the wonderful world of matrices.
The wonderful world of matrices begins on January 18th, 2012. Let's get down to business.
I'm Rix, and this is the history of matrices. It all started in 2nd century BC China, where they arranged the coefficients of a system into a group and performed operations to solve it. Then in Europe in 1545, Cardan created a rule for solving a system of two equations, which is essentially Cramer's rule for 2x2 matrices. Cardan's rule did not have a final step, and so does not reach a determinant like Cramer's rule. The term matrix was not used until 1850, when it was coined by James Sylvester.
Hi, I'm Mate, and now I'm going to teach you how to add matrices. We start off with two matrices, and they both have the same dimensions because that's the only way you can add them. Let's get started. First, we start with the corresponding coordinates. 40 and 39, we add them because they're in the same coordinate. You get 79, so we put that in the same coordinate in our answer. Then the second coordinate, we have 22 and 21. Those added together are 43, and we put that right here. Then, on our third coordinate, we have 12, and we have 53. Those added together are 65. And last but not least, we have our last coordinates, 23 and 46, which add up to 69, and that is how you add matrices.
Hello, I'm Rix, and this is how you multiply matrices. First, we need to find out if the matrices can be multiplied. Since these two are both 2x2 matrices, they can, because these two numbers match up, and the resulting will be a 2x2 matrix as well. So then, we have to take the sums of the products of each row and column, this row, this column, and that gets 72. In this row and this column, which gets us 41. And we move on to this row and this column, which gives us 86. This row and this column, which gives us 74. And that's how you multiply matrices.
Hi, I'm Mate, and right now we're going to find how to find the determinant. First, it's very simple with a 2x2 matrix. We start off with multiplying 12 and 8. So we go 12 times 8, and that equals 96. Then we do 5 times 10, and the answer to that is 50. Then we just then we do simple subtraction. 96 minus 50, and that equals 46. And that's how you find the determinant.
Guys, I'm Cramer, and I'm going to explain to you my rule that you guys might know as Cramer's rule. Cramer's rule can be used to solve a system of equations, and Cramer's rule states that when in the proper form of these forms, a1x plus b1y equals c1, and a2x plus b2y equals c2, that x equals the determinant of matrix c1, b1, c2, b2, over the determinant of the coefficient matrix, which I've written for you here, and y equals the determinant of a1, c1, a2, c2 over the determinant of the coefficient matrix. Before you begin to solve for the determinant of the upper matrices, you need to find the determinant of the coefficient matrix, which I've found to be is 1. Now that we've found the determinant of the coefficient matrix, we can go on to solve for x and y. We'll start off with x. Now x equals the determinant of c1 being 3, c2 being negative 1, b1 being negative 1, and b2 being negative 1, all over the determinant of the coefficient matrix, which we found to be as 1. Now the determinant of this upper matrix is negative 3 minus 1, which is equal to negative 4 over the determinant of the coefficient 1, making x equal negative 4. Now that we found out what x equals, I'm just going to erase this for extra board space, but I'm still going to keep written that x equals negative 4. Now we solve for y. Y equals the determinant of a1 being 1, A2 being 2, C1 being 3, and C2 being -1. A's are represented by the numbers next to the x's, B's are represented by the values next to the y's, and C's are represented by the values of the answers. Over the determinant of the coefficient matrix, we found it once again to be 1. The determinant of the F matrix is -1 minus 6, which is -7 over the determinant of 1, making y equal -7. Now you found your solutions to the two equations, and you can also write your solution as -4, -7 as a solution to the system of equations.
I'm Mate.
I'm Rix.
And I'm Cramer.
And we're signing off for the day. And just remember,
Matrices rule!